Welcome, everyone, to this deep dive. We're focusing today on a really fascinating intersection, AI and cybersecurity.
That's right. We're aiming to give you a clear picture of how artificial intelligence is, well, really shaking things up in how we defend our digital world.
Yeah, it's changing the game. We've got a lot of ground to cover today looking at some advanced AI defense techniques, but also the flip side, the threats to AI itself.
And even a little peek towards the future with quantum computing. The goal here is really to pull out the key takeaways, the core insights, without getting lost in, super dense jargon.
Exactly. Think of this as your shortcut to grasping the strategic significance of AI and cybersecurity right now. We'll look at why the old ways just aren't enough anymore.
Especially when the attackers themselves are starting to use AI. It's a whole new playing field.
So let's start with the defenses. How is AI pushing cybersecurity beyond those traditional approaches?
Well, one of the biggest shifts is in threat detection and analysis. AI, particularly machine learning, both supervised and unsupervised types, is incredibly good at sorting through massive data sets.
Data sets that would just overwhelm human analysts or older systems.
Precisely. AI can spot these really subtle patterns, anomalies that might indicate a threat, things that older rule-based systems would almost certainly miss.
Yeah, I saw a point mentioning these models can handle vast amounts of heterogeneous data to find those indicators much faster and more accurately.
Exactly. And that leads to this idea of more adaptive security. It's not static. AI learns, it refines its detection constantly.
So it gets better over time.
It represents, as one source put it, a significant evolution towards more adaptive and resilient security systems, better equipped for today's, frankly, much more sophisticated threats.
And it's not just detection, right? It's also about speed of response.
Absolutely. Real-time identification means you can potentially have automated responses kick in instantly, contain the threat before it
You
spread.
can cut down on the noise, the false positives.
Yes, definitely. By analyzing behavior and correlating data from different places, AI can be much more discerning. Fewer false alarms means security teams can focus on the real issues.
Okay, that makes sense. You mentioned analyzing data. What about understanding the structure of networks? I hear graph neural networks, GNNs, are becoming important.
They really are. GNNs are uniquely suited for cybersecurity because networks are graphs, essentially, nodes and connections. GNNs excel at understanding those relationships.
How does that help defensively?
Well, think about the cyber kill chain, the stages of an attack. GNNs can model these stages as a graph. Understanding how different events are linked, it helps disrupt the attack earlier.
Seeing the connections, not just the dots.
Exactly. And speaking of novel approaches, there's something called self-supervised learning for intrusion detection, or SSID.
Self-supervised. So it doesn't need humans to label all the data beforehand.
Correct. That's the key benefit. It can operate fully online, analyzing traffic, deciding what's normal or trustworthy, and flagging deviations, all without prior offline training or constant human input.
That sounds perfect for, say, IoT devices, where you might not have huge data sets or resources.
Precisely. It's designed to address that limitation, enabling deep learning IDS even in those trickier environments.
Very clever. And this ties into the proactive side too, right? AI helping with vulnerability management.
Yes. Instead of just reacting, AI can proactively scan systems and applications to find weaknesses much faster than traditional methods.
And prioritize them. Because you can't fix everything at once.
Right. It ranks vulnerabilities based on risk. AI algorithms can look through code, configurations, and NLP, natural language processing, comes in here too.
How so?
NLP can analyze things like threat intelligence reports, security advisories, forum posts, basically, unstructured text to pull out context about vulnerabilities and threats.
Got it. So it helps decide which patches are most critical and maybe even predicts future threats based on past trends.
That's the idea. It optimizes the whole vulnerability management process, making it faster and more targeted.
Okay, so AI is clearly boosting defense, but you mentioned collaboration and privacy earlier. That feels like a tension. How do we handle that?
It definitely is a tension. You want to share threat data, but you can't expose sensitive information. This is where techniques like Federated Learning, FLL, come in.
Federated learning, I've heard that term. Explain that a bit.
So imagine multiple organizations or even just multiple devices wanting to train a better security model together. With FL, they can train a shared model using their local data without actually sending that raw data anywhere central.
Huh. So the learning gets aggregated, but the data stays put.
Exactly. The model updates are shared, not the data itself. It decouples the machine learning from needing centralized, sensitive info. It's a paradigm shift for secure collaboration.
That sounds incredibly useful, especially with data privacy regulations being so strict.
It really is. And you can even enhance the privacy further by integrating something called homomorphic encryption. This allows computations, like the model training, to be done directly on encrypted data.
Wow, okay. So the data stays encrypted even while it's being used for calculations.
Yes, it takes federated learning security, another big step forward. Research is actively exploring this for things like intrusion detection.
That's pretty advanced stuff. But as you said, AI isn't just a shield. It can also be a target or even a weapon itself. This is the dual-edged sword part.
Right, and this is where we need to be really vigilant. Adversarial attacks are a major concern.
What are those exactly?
They're attacks specifically designed to fool or disrupt AI systems. The goal is usually to manipulate the input data in subtle ways to cause the AI to make a mistake.
Give me an example.
Okay, two main types. Poisoning attacks. An attacker might inject malicious data into the AI's training set, corrupting it so the final model is flawed or has hidden backdoors.
So you undermine it from the start.
Exactly. Then there are evasion attacks. This is where an attacker slightly modifies malicious input like malware just enough so the AI detector doesn't recognize it. It slips past.
That sounds tricky to defend against.
It can be. There's also model tampering, directly messing with the model, or prompt injection, which is a big one for large language models, manipulating the input prompts to get unintended outputs.
So even sophisticated AI can be deceived by cleverly crafted inputs.
Unfortunately, yes, it highlights a real inherent vulnerability we need to address.
And data poisoning seems particularly insidious, undermining the very foundation the AI learned from.
It is. It can cause misclassifications, degrade performance, or, as I mentioned, create those hidden backdoors for later exploitation. It can even be used just to make the AI unavailable. It's a serious threat to the AI's reliability.
Beyond attacking the AI's function, what about stealing the AI model itself? Is that a thing?
Oh, absolutely. Model theft or model extraction. These models often represent huge investments in intellectual property.
How would someone even steal a model?
Several ways. Maybe by bombarding it with queries to infer its structure, exploiting leaky APIs, or even insider threats.
And the consequences?
Significant. Loss of IP, loss of competitive edge, financial damage, reputational harm. It's a major economic and strategic threat.
Wow. And you mentioned large language models, LLMs, bringing new challenges.
Yes, definitely. As LLMs get integrated everywhere, they open up new attack surfaces. We talked about prompt injection, but also data poisoning specific to LLMs, using natural language interfaces to potentially sneak in things like SQL injection.
SQL injection through plain English.
Potentially, yes. Also, jailbreaking attempts to bypass safety controls and these complex compositional injection attacks, it really demands new ways of thinking about threat modeling.
Plus the ongoing challenges of securing critical infrastructure, like SCADA systems, as they get more connected.
Right. It's a complex threat landscape, and AI is right in the middle of it, both as defender and potential vulnerability.
Okay, let's shift back to the positive side for a moment. What are the key machine learning techniques driving these cybersecurity advancements?
Well, deep learning is a big one, using those multi-layered neural networks we talked about.
What makes deep learning so powerful here?
Its ability to process enormous amounts of data and find really complex, nonlinear patterns without a human having to explicitly define every single rule.
So it's great for intrusion detection, malware analysis, phishing.
Behavioral analysis, yeah, lots of applications. But there's a catch.
Which is?
The black box problem. Deep learning models can be incredibly effective, but sometimes it's hard to understand why they made a particular decision. Their internal workings aren't always transparent.
Right. Which makes it hard to trust or debug or explain an alert to someone.
Exactly. That's why explainable AI, XAI, is such an important area of research trying to make these models more interpretable.
Okay. What other ML techniques are key?
Reinforcement learning, RL. This is quite different. RL systems learn through trial and error, essentially.
How does that apply to cybersecurity?
You can train an RL agent by simulating attacks. It tries different defensive actions, gets feedback rewards or penalties, and learns the best strategies over time. It can adapt to new, unseen threats autonomously.
So it learns to defend by playing against simulated attackers.
In a sense, yes. It's about building autonomous, resilient defenses that can learn from experience in real time. You can even model attacker behavior or use multi-agent RL, MARL, for collaborative defense.
Fascinating. And the third one you mentioned earlier was NLP.
Natural language processing. This is all about enabling computers to understand and process human language text, mostly.
We touched on it for analyzing threat reports.
What else? Phishing detection is huge, obviously. Analyzing email text, but also monitoring social media or the dark web for chatter, analyzing system logs that contain text descriptions, even helping automate incident response by understanding ticket descriptions.
So it unlocks insights from all that unstructured text data that other tools might ignore.
Exactly. A massive, often untapped source of threat intelligence.
Okay, so these ML techniques are crucial. How are they being applied to secure these newer, sprawling digital areas like IoT and the cloud?
Well, for the Internet of Things, AI is becoming pretty much essential. The scale and diversity of IoT devices create unique challenges.
Like what? Just the sheer number of potential weak points.
That, and the fact that many devices have limited resources. AI helps with real-time threat detection, tailor IoT traffic, proactive vulnerability discovery and firmware, and enforcing security policies across diverse devices.
Can it help just figure out what's on the network?
Yes, AI-powered discovery tools provide that real-time visibility. Then there's behavioral analytics spotting when a device starts acting weirdly, which might mean it's compromised.
And handling the data volume. IoT generates tons of data.
Right. AI's ability to process that massive volume in real time is key. You can integrate it with things like deep packet inspection for really detailed analysis. It's indispensable for securing these complex ecosystems.
Makes sense. What about critical infrastructure? You mentioned SCADA systems.
Yeah, the increase in connectivity there is a major concern. AI, especially reinforcement learning, is being explored for autonomous defense systems that can react instantly to threats while trying to maintain operational stability.
Tricky balance.
Very. Digital twins, virtual replicas of the physical systems, are sometimes used as safe environments to train these RL agents without risking the real infrastructure.
And for cloud security, is AI helping there too?
Definitely, especially in multi-cloud environments where organizations use several different providers. AI can aggregate security data from all of them, giving a single, unified view.
That sounds incredibly helpful.
It is, and we're seeing AI-powered cloud detection and response CDR solutions emerge. These actively hunt for threats within cloud workloads and track any lateral movement if an attacker gets in.
So AI is really stepping up across these expanding frontiers. Now let's look even further ahead. Quantum computing. That sounds like a potential cybersecurity nightmare.
It does, doesn't it? The main worry is that large-scale quantum computers, when they become powerful enough, could break much of the encryption we rely on today, algorithms like RSA and ECC.
Basically rendering our current secure communication methods obsolete.
Potentially, yes. It's a serious long-term threat, but AI is expected to be crucial in navigating this.
By fighting quantum with AI.
In a way, AI will likely play a big role in developing and implementing quantum-resistant cryptography or post-quantum cryptography, PQC. New algorithms that even quantum computers can't easily break.
So AI helps create the next generation of encryption.
Exactly. And maybe, down the line, quantum-enhanced AI could lead to even faster threat detection. We might also see hybrid models emerge combining classical and quantum approaches. It's a future where quantum and AI capabilities, both defensive and offensive, will likely be intertwined.
A whole new era to prepare for. But even with current AI, there are ethical considerations we need to grapple with, right?
Absolutely. This is critically important. One major issue is bias.
Bias in the AI algorithms themselves.
Yes. If the data used to train an AI security tool is biased, maybe it reflects historical biases in arrests or focuses unfairly on certain demographics, the AI can learn and perpetuate those biases, leading to unfair or discriminatory outcomes.
And the black box problem makes it hard to even spot that bias.
It certainly can, yeah. Which ties into the need for transparency and explainability, XAI again. If we can't understand why an AI flagged someone or something, it's hard to ensure fairness or hold it accountable.
Accountability becomes tricky when the AI is making decisions autonomously.
Precisely. As AI gets more autonomous in security, we need clear frameworks for who is responsible if something goes wrong. Trust requires transparency and accountability.
And what about just the sheer amount of data AI analyzes? Privacy must be a concern.
A huge one. AI often needs vast data sets to be effective, and analyzing that data, even for security purposes, inherently creates tension with individual privacy rights.
So it's a balancing act.
It is. Careful data collection, anonymization where possible, transparency about how data is used, these were all crucial.
And the potential for misuse.
Mm.
AI being used for malicious purposes.
That's the other side of the ethics coin. We're already seeing AI used to make phishing scams more convincing, create realistic deepfakes for social engineering, enhance malware. Its power can definitely be turned to offensive cyber operations.
A lot to consider on the ethical front. Shifting back to innovation, what's happening at the frontiers of research right now? What's emerging?
There's constant exploration of new algorithms and tools. A lot of focus is on unsupervised and reinforcement learning, as we discussed, hoping to get better at detecting truly novel threats.
Refining deep learning too, I imagine.
Yes, always pushing for a better accuracy and efficiency in neural networks. And as mentioned, a big push for explainable AI. Also, people are exploring generative AI quite a bit now.
Generative AI, like ChatGPT, but for security.
Sort of, yeah. The potential there is quite broad, creating more advanced threat intelligence tools, maybe ones that can analyze emerging threats in real time and generate security insights automatically.
What else could generative AI do in this space?
Analyze compliance documents, help identify sophisticated deepfakes, even generate realistic attack scenarios for training and testing defenses, a kind of advanced sparring partner.
That's fascinating. So AI generating threats to help us defend against them. Are there good examples of AI already making a difference in the real world? Successful implementations?
Oh, definitely. We're seeing tangible benefits. For threat detection and response, you have companies like Darktrace using AI for anomaly detection, IBM's Watson analyzing threat data, CrowdStrike using AI to boost detection accuracy. These aren't just theoretical anymore.
And for vulnerability management.
Also, yes, NVIDIA has tools for scanning. Veracode uses AI to suggest code fixes. AWS has generative AI helping triage alerts. Tenable is even using AI to find vulnerabilities in other AI systems.
That's meta, securing AI with AI.
It is. And we see examples in IoT and cloud too. Darktrace has specific OT/IoT tools. Palo Alto Networks uses AI for IoT discovery. And various AI-powered CDR solutions are hunting threats in the cloud.
So the proof is definitely there. AI is delivering value. As we wrap up, what are the big future trends we should keep an eye on?
Well, one clear trend is the increasing use of AI in offensive cyber strategies by adversaries. We have to anticipate more sophisticated AI-driven attacks, phishing, vulnerability discovery, adaptive malware.
The arms race continues, powered by AI on both sides.
Pretty much. And the broader tech landscape keeps influencing things. Quantum computing forcing the move to PQC, where AI will help. The continued integration of AI with IoT and cloud demanding ever more specialized security solutions.
So it's this constant interplay between AI and other advancing technologies that shapes the future here.
Exactly. It's a dynamic and rapidly evolving field.
Well, that brings us to the end of this deep dive into AI and cybersecurity. We've covered a lot of ground, from advanced defenses and emerging threats to ethical considerations and future frontiers.
Hopefully this is giving you a clearer understanding of just how pivotal AI has become. It's not just a future idea, it's a current necessity for effective cybersecurity, even with the new challenges it brings.
Absolutely. It's a field that's constantly changing, and we've really only brushed the surface today.
Definitely encourage you to keep exploring these topics. The impact of AI on our digital security and our digital lives overall is only going to grow.